Hello, my name is Nguba. My project partner Neetam Moirangjam and Premashis Poles. We are UG final year students specializing in civil engineering from Beltech Rangarajan Dr. Saguntala R&D Institute of Science and Technology. This is our major projects in from the final years. Our project is about comparisons of strength characteristic of rattan cane with bamboo and steels. These projects have been carried out under the guidance of Dr. S. Suppiah. Now, came to the brief introductions about rattan and bamboo. The rattan is the name for roughly 600 species of old world climbing palms belonging to subfamily Calamoideus. It's Greek words, and it is also known as a Manila and Malacca, named after the forts of shipment Manila and Malacca city. This plant can grow up to 10 meters by climbing onto tree. When it came to the bamboo, bamboo is a perennial grass and not a tree as it commonly perceived, and these materials possess a good tensile strength and this lead to better performance during the earthquake, especially uh, hilly areas where the transportation is not adequate. So when we talk about the advantages of these materials is that the cost is efficient and it is environmental friendly, and bamboo is known as fastest growing plant in the earth. So due to unique rhizomes dependent systems, the sum of bamboo's species can grow 91 centimeter, that is 36 inches, within a 24 hours at the rate of almost 4 centimeter, that is 1.6 inches an hour. When it came to India, the 60% rattan canes found in Arunachal Pradesh and 20 to 30 percentage of rattan cane found in Andaman and Nicobars, and 10 percentage found in Western Ghats. Came to the objectives: to evaluate the strength characteristic of rattan cane, to compare the strength characteristic of rattan cane with bamboo and steel, to evaluate the flexural strength of slabs reinforced with rattan, bamboo, and steels. The scope of our project is to determine strength characteristic of rattan cane as well as to find the flexural strengths of slabs reinforced with rattan cane, bamboo, and steel, and then compare the values among them. Comes with pioneering works by leading researcher. So the first one is Glenn's H.E. He worked on bamboo reinforced in Portland concrete in 1950. Francis E.B. and Ford J.R. work on bamboo reinforced concrete construction 1966. H.M.A. Ahmad work on determination of tensile strength, stress, and bond stress with concrete of rattan. Ethikulan and others work on comparative study of steel, bamboo, rattan as reinforcings bar in concrete in 2015, and Priyadarshi Das work on cane reinforcement cement concrete and experimental approach on flexural strength characteristic in comparisons with steel RCC in 2016. Came to the methodology. These are the methodologies which we carried out and which we proceed to execute and accomplish our projects. First one is literature study, then we select the materials, that is canes and the bamboos, and we follow the various treatment process to rattan cane with varnish, coconut, and salt solutions, and then rattan cane specimens were allowed to dry for 10 to 14 days, and then we did the mix design and testing, and then we cast and cast the slabs and then let it cure for 14 days, and then we tested the slabs. In figure 3.1 flowchart, it's showing the process steps for rattan cane. It's not only for the rattan cane, but it's also the process which we carried out to complete our projects. So collection of material. These are the material which we use in our projects. One is Calamus Pilosselluse, which is collected from the northeast, and Demonerops jenkinsenia, collected from the Bangalore. These are the method of treatment of rattan cane. First one is with the burnish. In this, the specimens were cut into 50 centimeter and rubbed with the sandpaper. Then apply the burnish of 3 coating layer at the interval of 30 minutes for the and it's dried for the 24 hours at room temperature. And the second one is same as that of the first one, only different is that after the third layer of 30 and with 30 minutes intervals dried, the sand has been sprayed over a surface of rattan cane. And the third method is treated with coconut oil at 100 degree to 120 degree. In this, the rattan specimens were cut into 50 centimeter and the half liter of coconut oil was boiled and confined at 100 degrees Celsius to 120 degrees Celsius. And the rattan cane were placed inside the boil it for 10 to 20 minutes. The boiled cane were kept in vertical to drain soak oil for 24 hours. The fourth method is same process as that of method 3, but the only difference is that in this fourth methods we use salt solution instead of coconut oil. And for the salt solution concentration, 5 teaspoons of salt were dissolved in 1 liter of the water and boil it confined container again at the temperature of 100 degrees Celsius to 120 degrees Celsius. And these are the image which is showing the different methods of treatments. First one is coated with burnish, second one is called burnish and the sands, third one is treated with coconut oil, fourth one is treated with salt solution. And we came to the test part. These are the testing which we carried on rattan cane and the bamboo. First test which we have carried on the rattan and bamboo is moisture content test. In the moisture content test, we cut the specimen in at equal length of 5 centimeter, that is 50 mm, and place it in oven for 24 hours at 60 degree Celsius. And in this table number 2 showing in table number 2 the specimen type, there is a 2 specimen type, rattan cane and bamboo specimens. For the rattan we did the 4 specimens, 4 different trials, and for bamboo we did the 5 different trials. And here W1 denoted the weight of samples before oven dry, and W2 denoted the weight of the sample after oven dry in grams. So from the formula we calculated the percentage of this water content by using the formula W1 minus W2 divided with W1 into 100 will give you a average percentage of average moisture contents of rattan as well as of the bamboo. From the tabulations we can see that average moisture content of rattan is much more lower than that of the bamboo, which is 9.27, is lower, less than that of 21.757. Second test which we have done on bamboo and rattan canes is density. In this the process, respective materials were cut into the piece into 50 mm, which is 5 centimeters, and measure the weights as well as the dimension of bamboo as well as rattan. And then we weighted the we weight the samples weight and calculate the volume by using the dimensions. And for the volume calculation purpose, the bamboo is bit of rectangular shape, so we use the formula length to bring into height. And for the rattan cane it is circular in shape, hence we use pi d square by 4 into length of the specimens. From this we can see that density of samples of bamboo will come under 800 kg per meter cube. The average will be give 800 kg per meter cube, and the rattan cane will give somewhat 850 kg per meter cube. And the table number 4, it shows the dimension of the respective materials. Came to the specific gravity test on bamboo and rattan cane. In this we use weighing machines of accuracy 0.01 gram accuracy, and then these the table 5 specific gravity on the table 5 shows the specific gravity on bamboo and rattan. So first one is the bamboo and second green one is rattan cane. From these we can say that specific gravity of rattan cane is 0.5 to 1, and bamboo is 0.5. By using the formula W2 minus W1 divided by W4 minus W1 minus W3 minus W2. So here the W1 is denoted the weight of the 5 km in gram, W2 denoted the weight of the 5 km plus bamboo 2, W2 in gram, and then W3 denoted the weight of the 5 km plus bamboo plus water, and W4 denoted the weight of the 5 km plus water only. And now came to the next test, which is, that is tensile test on rattan cane. Tensile test has been done on all specimens, different specimen like rattan cane, bamboo, as well as the steels. The first table number 6 is showing the rattan tensile test, the valuations of tensile test on rattan. So tensile test, the value has been compiled from the test that which is carried on the UTM machines, which is shown in figure number 6. Figure number 6 is showing tensile strength of the rattans, and here there is a 4 different methods of the treatments with the rattan cane. Hence every treatments methods we carry 3 samples. We carried out the 3 samples for test 3 sample test with the test on the rattan cane. So tensile test on rattan cane, that is what I'm saying is treatments with burnish. The first one is treatment with burnish. For the treatment of the burnish, we did the 3 trials, and then we calculate the average value. So it is showing that 44.133 is the average value of 3 samples. Likewise, treated with varnish and spread of sand, and similarly for treated with coconut of oils and treated with salt solutions, and finally untreated rattan cane. So from these the tabulations we can say that the 62.938, which is treated with the salt solutions, is give higher tensile strength value than among others. So you can see here in figure number 6 there is a the instrument which is having a 2 dial gauge. These instruments are used to find the elongations while we are applying tensile load on specimen. So this is only applicable for the 10 centimeter only, and by using this we are trying to find for the 100 mm 100 mm length elongations with respect to the load applied. So came to the tensile strength test on bamboo, same as before, which is tabulation. In tabulation 7 it's showing that the value sample 1, sample 2, and the maximum load has been shown, and ultimate load which we get while it's cracked, while it's failure, at the failure, and then area which we calculated from the dimensions, and then we find the tensile strength by using the formula load by area, which will give you a Newton mm square. So we, and after this specific sample we find the average value, which is 66.763 Newton mm square. And this image, figure number 7 image, showing that the bamboo tensile strength of the bamboo after failure. So tensile test strength on the steel same as that of the before, and compilation value have been shown in the below table number 8. So these are the maximum load in a UTM, that is 100 kilonewton, and ultimate load which we get from the UTM is 52, 51 and 50 from the three specimens of the steels. And then area had been calculating using the formula pi d square by 4. And in here tensile strength have been calculated Newton for mm square, and then we finally calculated the average value of tensile strength of steels, which we get 657.846 Newton mm square. So this is the load versus deflection of graph of Rattan Cane. Load, the graph is plotted load with respect to the deflection. So these are the three samples, and after plotting this graph, and we get the average average of these three, and take as a valuation of Rattan Canes. So sample 1, sample 2, sample 3 in a tabulations, its a length is same and the diameter is bit of different, but because of the diameter difference there, the value, hence the value is different. So came to the next test, which is stiffness test on Rattan Cane. So in stiffness test of Rattan Canes, which was carried by the idea of Maxwell reciprocal theorems. In the Maxwell reciprocal theorem, it states that if there is a 2 points, say A and B, with a different distance, then when we apply the point A and take a deflection at point B, will be same value when we apply the load at B point and take a deflection at B. Then that is the principle of Maxwell reciprocal theorem. In the table 9, it shows that the first one, serial number and the loading position, different loading position, point A and point B as well. And we find the stiffness by using the formula load by deflection. Load by deflection will give you a stiffness of the materials. Same as the before, it is stiffness test on the bamboo. And here the dimension calculations of area is gonna be different, but area is not necessary, hence so we need the point load and the deflection. So the stiffness test, stiffness on bamboo can be calculated by load by the deflection. So these are the value which we get on bamboo, stiffness on of the bamboo. The first the last columns which is showing first one is for at the center loading we get 1.142, and for the point A 2.440, and point B 2.522. and the pictures below the picture are showing the loading process and the loading positions of Maxwell reciprocal theorem with respect to point A and as well as for point B. Now came to the stiffness test on steels. These are the steel stiffness test on steels has been carried out to make as a benchmark, to keep as a benchmark for the comparisons purpose. So for the in table number 12, comparisons of stiffness between Rattan Cane, bamboo and steels has been shown. From this we can see that central loadings as well as the right side loading, that is point A, and the left side loading point B. Point B, it's showing that 17.958 and 8.077 is much more higher than that of the Rattan Cane and as well as bamboo. Now came to the comparison comparison tables of tensile strength between among the Rattan Cane, bamboo and steels. First one is the material rattan, bamboo and steel, and then second column showing the tensile strength. From these you can see that 662 is much more greater than 66 and 62 of rattan cane and as well as the bamboo. Remark is that treated with the salt solution has been used in this comparison purpose, and then and for the bamboo, treated bamboo has been used, and for the steels, mild steel to Fe215 has been used. Below figure number 15, it shows that bar chart the comparison among the three tensile strength among the three. So now in here, after these are the physical the whatever we just saw, they are physical property test. So now after the physical property test, the based on that physical property test, we designed a mix, we did the mix designs, and we cast the slabs, and after casting the slabs, let it cure for the 14 days, and then we tested. So now I'll show you the test which have been done, the flexural test on a slabs. So first testing of the slabs reinforced with rattan cane, bamboo and steels. First one is table number 14, which is showing the flexural test on rattan cane reinforcement slabs. The first column shows the it's a load. These testings on slabs reinforcements have been carried out on a loading frames which is capacity of 300 kilonewton, and you can see here the load for first columns. There is a load. The first column is a load, and the second column is a deflection, and the third columns is deflection. We find by using the dial gauge and keeping below of the samples. And the flexural, third one is the flexural strength in trial 1 and trial 2. Flexural strengths were found by using the formula 3 FL upon 2 BD square 3 into F denoted the load, L is the length, and upon 2 into breadth into depth of slabs square Newton per mm squares. And these are the flexural value of rattan cane, and then we plotted the graphs against load versus deflection in mm. Now same as before, the flexural strength test on the bamboo reinforcement. This is for the bamboo trial 1, trial 2. Same load position, same deflections, and the flexural has the same formula has been used to calculate the flexural strength. And these are the value, and below their average flexural strength 1.67 Newton mm square is showing. These are the average value. And for the bamboo, and figure number 16 shows that the graphs plotted against load versus deflections of bamboo reinforcement slabs. Now came to the flexural strength test on the steel slabs. Same as before, as I told you, the trial 1 for the trial 2, and loading position. These are the load, and these are the deflections with respect to the load, and the flexural strength has been calculated using the same formula with respect to the load, and the graph has been plotted with respect to load versus deflection in mm. Now came to the image. So this first one image is rattan cane slabs, and second one is bamboo reinforced slabs, and the third one is steel reinforcement slabs. So these are the different slabs which we tested and tabulated and did the calculations from, so we can conclude and comparing the values among them. Now came to the result in the discussion. In the result in discussions, we plotted a tabulations. Table number 17 is physical property of bamboo, and the first columns denoted represent type test types as we see before. As you saw before, the moisture content, specific gravity, tensile test, stiffness loadings, and these are the values, a result which we get from the observation and calculation. Same as for the table number 18, the physical properties on rattan cane, and these the first columns denoted the types of test, and second columns is on of result. And as same as before, table number 19, physical property of steel. First column denoted type of test, and second is result of observation and the calculation. And the final tables, this is showing the comparison of initial crack, that is at the initial crack of slabs. And with respect to the initial cracks, we calculated the flexural strengths among the rattan cane, bamboo, and steel reinforcement slabs. So from this we can see that initial crack of slabs reinforced with rattan cane is 5.7.50, and then slabs reinforced with bamboo is 5.50. Slab reinforced with steel is 10 kilonewtons. And then with respect to the load, we calculated the flexural strength as we see before, the formula 3 FL divided by 2 into VT squares. Now came to the graphs. This graph showing the comparisons among three materials: rattan cane, bamboo, as well as the steels. With respect to the initial cracking load, that is, this load is only plotted up to the initial crack. So conclusion came to the conclusions in from the result and discussions, we can conclude that steel reinforcements have a higher magnitudes of flexural strength, which is shown in 3 Newton mm squares, which is much more higher than that of both the rattan cane slabs 2.25 and the bamboo reinforcements like 1.65. It shows that this material can replace the steel's alternative reinforcement materials, and these materials is very suitable for hilly areas where the adequate transportation is not available. And application for these materials, bamboo as well as for the rattan cane, is that it can be adapted at low cost structure such as cow bones, peggies, lightweight supporting slabs, and the temporary structures. And it is especially useful for the economical the very backwards economical countries such as India. And these are the references which we refer before we execute our projects. These are the references where we get the ideas and the IS codes and everything which we get to execute our project and accomplish our projects. These are the references. Thank you so much.